Hello. In this video, you will learn about factoring, and we will be using a technique known as the difference of cubes. We will be factoring cubic expressions, meaning the exponent is going to be 3 or multiples of 3, 6, 9, and so on. We will start by analyzing the formulas. We will focus on the top one since we are looking at the difference, but the bottom one, which is sum, this is plus, this is minus, is very similar to the difference of cubes. So one thing to point out is this part right here would be the problem, the one I'm enclosing in light blue, and as soon the other part on the other side would be the what we're trying to get. That would be the factor form. As you can see, this is a difference. That means this is a minus. These two right here are actually the same. So the sign on the first parentheses will be the same as the sign on the problem. I also have to note that the first sign on the second parenthesis will be the opposite of what that one is. And lastly, the last one, this one right here, is always a positive number. On the bottom one, it would be the same. If you look at the first sign, they're the same. The first sign on the second parenthesis is always the opposite. And the last one will always be a positive. So we will be using the above equation in order to solve this type of problem. Okay, we're going to be looking at factor using difference of cubes. We will make the problem look like the formula down here. Once the problem looks like that, we are done. So there are 4 steps in order for us to be able to use the formula at the bottom. Step number 1 is the highest exponent 3 or a multiple of 3 on the variable. So there it is. We have an exponent of 3. We have a check for the first step. Do we have a subtraction sign? We do. Check for the next one. Now we have to look at the first term. This is the first term, and we are trying to determine if this is a perfect cube. In other words, is there one number or variable that if you multiply it times itself twice, it'll give you x cubed? If we multiply x times x times x, we're multiplying x times itself twice, we get x cubed. So that one works. We have to try the same thing on the second term. Is there one number that when we multiply it times itself twice, we get 27? 3 times 3 is 9, times 3 is 27. This one also works, therefore we'll be able to use the formula. Let me start by prepping it up. The formula uses the letters A and B. A is for the first term, so in this case we are going to say that A is equal to x. B is equal to 3. So we're picking one of the numbers that we multiply times itself for the first and second term. Now we will write out the 2 parentheses that we'll be using for the formula. 1, 2. Now, if you remember from the previous slide, this symbol right here, which is a minus, will be the exact same thing as that one. So, because we do have a minus, this one will be a minus. And then the first symbol on the second parenthesis will be a plus. The last one is always a plus. So this would be it for difference of cubes. Now let's look at the formula. The first letter right here, I'm looking at the formula box, is A. We know that A is x, so I will be putting an x here. The second letter in the formula is a B. B is 3, I will be putting a 3. If we look to the second parentheses, the first letter is an A square. So A is x, I'm going to put x, but I want that one to be square. Then we have A times B. A times B would be x times 3 or 3x. And the last one is B square. B is 3. 3 squared is 9. And we would be done with the problem.